All right, so guys, look at the next one here. It says use the confidence interval to find the margin of error and the sample mean. Okay, so guys, remember how we were doing, we did a problem like this earlier, actually, I think in 6.1. So if this is our, remember how we're finding the confidence interval? We're taking the X bar and we're subtracting the error, and we're taking the X bar and we're adding the error, right? So if our interval here is from 12.4 to 21.4, in essence, when we're trying to find our X bar, we're looking for the number that's right in the middle, aren't we? Okay, so when we did this the other day, didn't we say what we needed to do was add those two numbers together? And then do what with it? Okay, cool. Man, y'all remember everything. Good, let's see. 12.4 plus 21.4. And coming up with 33.8. And divided it by 2. So, guys, I'm coming up with my X bar to be 16.9. Okay. Equals 16.9. Okay. Y'all remember how we're going to find the margin of error E? From the formula, right? But we don't even have to use the formula, right? Can't we say, look, if there you go, right? We could go 21.4 minus 16.9. $4.5. So yeah, the other way we could do it, let's see, this is 4.5, right? Or the other way we could do it, instead of taking 21.4 minus 16.9, couldn't we take 16.9 minus 12.4? Right? And wouldn't we still get 4.5? Right? Because we're looking for that point in the middle. So we're just trying to figure out, remember, if the mean is 16.9, then that means we're going to go 4.5 this way and 4.5 that way, right? So whichever way you do it, you should be coming up with the same answer, right? Okie dokie. Okay, so guys, now the question is, so when we were here on Tuesday night, one of the things that we did was like the quiz that we just took, right? We were finding the ZC score, right? And then on when we were doing these other problems, remember the table we're using, guys, or we were using on our calculator, weren't we using the inverse t function, right? So the question often is, how do I know which one I'm going to use? Okay. So guys, number one, just to kind of make sure that we all remember what's kind of going on here, I'm going to pull up what I had up a little while ago before, because I want to make sure that we all remember these things. Where was it? Where's my test, chapter 1 and 2? Okay, so guys, the one thing I want to make sure that I understand is when I'm looking at the information that's given to me, I have to remember what each of those little sort of symbols stand for, right? So we talked about this the other day. We said, look, like the population mean is mu, right? The sample mean has the X bar. And then we have the population standard deviation, which is the sigma. And the sample standard deviation, what's the symbol for the sample standard deviation? The S, right? Okay. So when I come back over here, look what it's asking me. Is sigma known? Remember, sigma is the population standard deviation, okay? If I do know sigma, then I'm going to use the normal distribution, and I'm going to find my ZC score, which is just what we did right now in our quiz, right? And if I don't know my sigma, then what they should be giving me is they should be giving me the sample standard deviation, okay? So if I don't know sigma, then I'm going to know the value of S, okay? I'll know one of those two. I'll either know the sigma or I'll know the S. So if I know the sigma, this is the one that I use. If I know the S, then I'm going to use our inverse t function to find that TC value, okay? So look, I'm going to kind of bring this up a little bit so we can take a look at number 5. Number 5 says we select 25 newly constructed houses. Okay, so guys, before I start even reading the rest of the problem, that tells me that my number n is what number? 25. Okay. Now look at the next part. It says the sample mean cost is 181,000. What variable or what symbol do we use for sample mean? Good. Excellent. X bar is equal to 181,000, okay? And then look what it tells me here. The population standard deviation is 28,000. What symbol do we use for population standard deviation? The little sigma, right? The little O with a hat, okay? That's equal to 28,000, right? Okay, now the question says, assuming construction costs are normally distributed, should we use the normal distribution, the t distribution, or neither of them to construct a 95% confidence interval? So let's think about it this way. What I want to ask myself is, did we know our sigma? Yeah. So when we know our sigma, we're going to use the normal distribution, okay? When we know the sigma is going to tell me the population standard deviation, and that's the one that I'm going to end up using, okay? Guys, let's go ahead and see if we can find that confidence interval. So number one, the level of confidence. What was the confidence interval we were looking at here? Yeah, very good. So 95%, so 0.95. Okay, so guys, I'm going to show you how we can come up with the answer without having to do a whole lot of calculations. We can come up with the answer fairly quickly, okay? So, guys, the first thing I'm going to do, I'm going to grab my calculator, I'm going to turn it on, okay? I'm going to clear all this mess out. I'm going to go to Stat, guys, and I'm going to scroll to the right till I hit Tests, okay? And because we are using the normal distribution, we're going to go to the Z interval, okay? So you know what, before I do anything else, let me just write down what we're doing. We're going Stats. After Stats, which one did we select? Tests, right? And after that, we selected the Z interval, right? Okay. Okay, guys, the reason why we're using the Z interval, because we had sigma, okay? So let me come back over here. Okay, Z interval, I'm going to hit enter. All right, now look what it's asking me. Do I want to hit data or do I want to hit stats? I'm going to go to stats, okay? I'm going to hit enter. And look what it's telling me. It's giving me all these variables, okay? So in our case, what was our sigma in this case? Okay, so let's enter that number in, 28,123. Okay, move my calculator back this way. Okay. Let's see, our X bar. Did we know our X bar? 181,000. Okay, 1, 2, 3. Okay. Our N level. Did we know our N level? 25, because we're looking at 25 houses. Okay. And what was our confidence level? 0.95. Okay, it's already there for me. So you don't got to do much. I don't know if yours already had a 0.95. Anywho, now I'm going to go ahead and hit calculate. Okay, so it gave me that interval. Guys, all I'm going to do is I'm going to copy it down here. So let's see, 170,024. 170,024. And I'm going to take away that extra parenthesis, that extra comma, because it'll look like I'm writing too many commas. Okay. And what was the other one? What was the bigger number? 191,976. Okay. 191,976. Boom. So all we're saying is that our population mean is going to be somewhere in that interval there. These houses are going to be anywhere between 170,024 to 191,976. So far, so good? That's the answer. Okay. Yeah, so yeah, exactly. This is our population mean, right? So we're finding that our population mean, 170,024 and 191,976. And remember, this is in what, dollars? So what we're saying here is like, look, we took 25 homes, right? And we found the sample mean of those homes, and we knew the population standard deviation, right? To find our 95% confidence interval, what we're saying is that we're 95% sure that the population mean is going to lie between the numbers 170,024 and 191,976, right? That the mean of all the houses is going to be in that range, okay? So guys, do me a favor. Let's take a look at the next problem, number 6, okay? And we're going to try to do exactly the same kind of thing, right? So look, I'm going to start reading, and I'm going to set this up just like we did in number 5. We randomly select 18 male athletes. Okay, so what is that first number telling me? That's our n, right? Good. So n is equal to the number 18, okay? And we measure the resting heart rate of each, okay? The sample mean heart rate is 64 beats a minute. Okay, so guys, what is this part telling me? Okay, so what variable do I use for that one? The x with a little bar on it, right? Good, excellent. X with a bar is equal to 64 beats per minute, okay? Now look at the next thing it tells me. With a sample standard deviation of 2.5 beats per minute. Guys, if I pull up again, just to make sure we understand, take a look right here. What variable do we use for the sample standard deviation? S, right? Okay. So let's come back over here. So we know that our S in this case is 2.5 beats per minute, okay? Assuming the heart rates are normally distributed, should we use the normal distribution, the t distribution, or neither? So if I switch back over here and I come back to this problem here, okay, did we know in that case, did we know our sigma? No, but we knew which letter? We used the letter S, right? So guys, when we have the letter S, we're going to use which distribution? The t distribution, right? Okay, so this is going to be a t distribution. Okay. Now, let's take a look at one more piece of information. What's our confidence level going to be here? 90%. Okay, so that just means that my letter C is going to be 0.90. Okay, guys, I'm going to grab my calculator one more time. Let me clear this out. And I'm going to do this just like we did the other one. We're going to go to Stat. And then after Stat, we go to which button? Test. We're going to go to Test. Oops, too many times. And then, guys, what I want you to do, I want you to scroll down. And if you look at number 8, at least it's number 8 on my calculator, it's the t-interval test, right? So I'm going to hit Enter here. Okay. And guys, again, I want to go directly to Stats. I don't want, if it's on data already, just move it over to Stats, hit Enter. Okay. And now my X bar, did we know our X bar in this case? 64, right? Okay, so we're going to go 64, that's my X bar. Look at the next variable. So it has the S. Did we know our S? 2.5. So we're going to go 2.5. Okay. N, how many, what was our N in this case? So we're going to put an 18. And then we're going to calculate our, our confidence level. What percent was it? 0.90. So we're going to go like that, 0.90. And we're going to hit Enter. And let me see. There we go. Okay, so guys, I'm going to go ahead and write down the same thing that we have there. 62.975. 62.975, comma, and the other number was 65.025? 65.025. Boom. Okay. So again, I'm glad Myra asked me that question earlier. All this is telling us is that the population mean should be between these two numbers here. And guys, again, just so that we understand, what are those numbers representing? They're representing what? Resting heart rates? So beats per minute, right? So this is telling us that the population average heart rate, right? If we were to take all male athletes, they didn't give us a range like, you know, are these male athletes that are between 18 and 28, or are they, you know, how old are they? I don't know. They didn't give us very much information, right? But we're to take these male athletes, maybe all of them, and we were to find the average heart rate, right? The average heart rate of all of them should be between 62.975 beats per minute and 65.025 beats per minute. Make sense? We're good? Okay. So let's take a look here, guys, at number 7. So I think this is the last problem here in 6.2. Let's take a look here at problem number 7. It says the SAT scores of 12 randomly selected high school seniors is shown. Find the sample mean, the sample standard deviation, and construct a 99% confidence interval for the population mean. Let's see. Assume the population is normally distributed. Use technology if you wish. I don't know about you, but I wish. Right? Because obviously, look, guys, when we did those last two problems, weren't they really, in essence, very easy to do? Once we know which test we're going to use, it's pretty simple to figure out, to actually do the test, okay? So look, let me grab my calculator. I'm going to clear it out. Now, guys, look what we have here. These are the scores, right? So remember what I have to do. I have to go to Stat. I'm going to edit, right? And I have to put these numbers in my list. Okay, so look, let's start entering the numbers in. 1700. Okay. I'm just going to go left to right. 1940. Okay, so if you need to clear it out, just go like this. Go to the very top where it says L1. Hit clear, and then hit enter. We're good? Good. Excuse me, 1700. I got 1940. Sorry guys, it takes me a little bit longer having to use the mouse. 1510. 2000. 1430. 1870. 1990. 1650, 1820, 1670, let's see, 2210, and 1380. Enter. Okay, so there's our 12 people, right? Now guys, remember what I'm going to do now? I'm going to come back to Stat, right? I'm going to go to Calc because I want to calculate my one variable stats. Okay, guys, on my calculator, because again, this is a little bit of this. I have an 83 up here. I know most of y'all have an 80, 84, 84 plus. So guys, when you do yours, and let me just kind of switch over real quick so you can see. Let me see. Here we go. If you had yours, right? And let me clear this out. Second stat. Oops. Sorry. Stat. Okay, you would go to calculate, right? So mine's not even the same one. This one's not even as updated as the other one. I think I have a more updated one here. Yeah, because yours is probably more like this, right? So if I go clear, stat, calc, one variable stats, yours looks like this, right? Okay, so guys, on their frequency list, just delete so that there's nothing there. Okay, if your list is clear, like if you don't have anything in your list, it doesn't really matter, but that's basically what it is you want to do, okay? So let's see, I'm going to come back over here, my one variable stats, enter. Okay, are y'all coming up with the same numbers? We're all good? Okay, so guys, let's see. The first thing I'm going to do, I'm going to just kind of minimize this for a minute because I want to make sure I know what they're asking me to do. So look, the first thing is they're asking me to find the sample mean. Okay, everyone agrees sample mean is my X bar? Okay, so what was our X bar? Guys, let's go ahead and round it to, let's put two decimal places, that's fine. So 1764 point, okay, 1764.17, 1764.17, okay. Now the next thing they want to find is they want us to find the sample standard deviation, right? So guys, if I grab my calculator again, my sample standard deviation, isn't that my S? So guys, if we were to go to two decimal places here, what number would I use? 252.35? Okay. So S is 252.35, okay. All right. Guys, did we know what our N was in this case? N was 12, right? Because didn't we enter in 12 grades? Okay. And what is our confidence level here? 0.99, right? Okay. So guys, my question to you now, when I come back to my calculator, right, I'm going to clear this out. When I go to Stat and I scroll over to Tests, which one would I use? Would I use the Z interval test or the T interval test? The T interval test. Everybody agree the T interval test? Okay, why am I going to, very good question. Why am I going to use the T interval test? Because we have the sample one, right? So guys, remember, all we got to remember is if I have the sigma, I can use the Z interval. If I have the S, then I have to use the T interval, right? Okay, so let's see. Bring this right here. Okay, we said we're going to use the T interval, so guys, I'm going to go like that. And let me see. Did it already put all that information for me? Parece que yes, right? The only one that we have to fix is which one? The sea level, right? So what number are we going to put? 0.99. Okay. We're going to calculate it out. Boom. And let's take a look and see what we got. I wonder if the 83 just takes a little bit longer because it looks like it runs a little slow. 1537.9 to 1990.4, right? 1537.9 to 1990.4.
The words that are going to determine population and sample.
That's right. That's right. So very good, guys. So Fred's question is again, how do I know which one I'm going to use? So look, guys, give me a flavor. If you go back to this part right here, which was I think on the previous page, right? At kind of at the top of the previous page. Think about it this way. So let's go like this. Here we're going to go Z interval because we have sigma. And here we're going to go T interval because we got the letter S. Better? So think about it this way. Sigma, Z interval. S, T interval, right? And again, how do I know which one I have? So remember, just to kind of give you a heads up, how do I know which one do I have? When I look at this part right here, if it tells me I have my population standard deviation, then I have my sigma, right? That's right. If I have my population standard deviation, I have my sigma. And if I have my sample standard deviation, then I have my S, right? And so in that last problem that we just did right now, right? So guys, when we did that last problem right now, let me see. Pull it back up. Okay, when we did this last problem right now, and didn't we go to our calculator? Let me pull it up again, clear it out. We did stat, right? And we did calc, and we did our one variable stats. And we came up with those numbers, right? Now, let me ask you a question. Does my calculator tell me both the sample standard deviation and the population? Okay, so I actually have both, right? But how did I know which one I was going to use? The question, right? Look right here. What was it asking me for? The sample, right? That's how we knew we were going to use the S. Does that make more sense? Boom. The numbers? Was it, did you do the t-test? Okay, so guys, let me pause this real quick.